So in this video we're going to look at topic 2.9, which is gas chemistry, which is essentially a topic where we look at the key characteristics of a number of gases we find in the atmosphere around us. So the first thing we have to know is actually what the gases are that are in the atmosphere around us, otherwise known as air. We find a number of different gases in the air around us, and they're in different proportions, so we have to know the various percentages for these different gases off by heart. The main gases in the air around us are nitrogen and oxygen. 78% of the air you breathe in is nitrogen and 21% of it is oxygen. There are slightly smaller percentages of argon, which is a noble gas, and carbon dioxide, which is 0.03 to 0.04%. You'll also find water vapour in the air around you, but that will depend on the humidity in terms of what percentage you have. And there's also very small percentages of the other noble gases apart from argon you'll find in the air around you. So now we take a number of gases that are important in the atmosphere around us and look at them in turn and look at their key characteristics. The first gas we look at is nitrogen. The first thing we need to know for nitrogen are its physical properties. Nitrogen is colourless, odourless, which means it doesn't have a smell, neutral, which means it's not acidic or alkaline, and also insoluble in water. The second main characteristic of nitrogen is that it's very unreactive and won't take part in many chemical reactions. The reason for that is due to the bond that you'll find in a nitrogen molecule. Nitrogen is diatomic, which means it always comes as pairs, and the two nitrogen atoms in that diatomic molecule are joined by a quite unusual triple covalent bond. What we find is that the triple covalent bond is very, very strong, and therefore if you want the nitrogen to react and to break that triple bond, it requires a lot of energy, which basically means that it's going to be very unreactive because you don't often have that amount of energy to break that triple bond. The final thing we need to know about nitrogen are its main uses in the world around us, and there's three ones that you maybe would have to know about. Nitrogen can be used as a coolant. Liquid nitrogen is a very cold substance that can be used to freeze and preserve substances. Food packaging is another use. Because nitrogen is so unreactive, if you put it around food, the food takes a lot longer to go off. So inside packets of crisps you'll find nitrogen, which is known as an inert atmosphere, inert meaning unreactive. And finally, we've got this unusual use in the manufacture of ammonia. Ammonia, as we'll look at in the next section, is a key starting material to make fertilizers, and we make ammonia from nitrogen. So the next section we move on to is ammonia. Now ammonia obviously isn't a gas we find naturally in the atmosphere, but it's an important gas that we can make from nitrogen, so that's why we look at it here. First thing about ammonia is its key characteristics. In physical properties, it's a colourless, pungent gas, pungent meaning very smelly. It's also a compound of nitrogen and hydrogen. Its formula is NH3. One thing you have to know about ammonia is a chemical test for it to prove that you'd have some ammonia. It's quite a complicated sounding test, but you just need to remember the key steps in it. Basically, you'll take a glass rod, you'll dip that glass rod into concentrated hydrochloric acid, so it's kind of wet on the end of the rod. You'll then bring that kind of damp rod over to what you think is your ammonia gas, and if it is ammonia gas, you'll observe a white smoke being formed. The main use of ammonia in society is to make fertilizers, specifically artificial fertilizers, which help with crop growth and the yield of crops grown in fields. How we make fertilizers is we take ammonia, we'll react them with an acid to make what's called an ammonium salt, and the ammonium salt you make is actually what the fertilizer is, which you can sprinkle on your soil as a fertilizer. There are three main acids you know about from year 11, hydrochloric acid, sulfuric acid, nitric acid, and therefore there are three main ammonium salts you'd have to know equations for their formation. So the main equation we use is that ammonia plus an acid will make what's called an ammonium salt. There's three different reactions you know about. You can essentially learn them off by heart if you want. This first reaction is between ammonia and hydrochloric acid to make what's known as ammonium chloride. The ammonium ion on the back of your periodic table is NH4+, the chloride ion is Cl-, so if you swap and drop that you get NH4Cl. The second reaction is between ammonia and sulfuric acid to make ammonium sulfate. Here we need two ammonium ions because the sulfate ion has a 2- charge, and we need to balance the equation with a 2 in front of the NH3. And in the final reaction, ammonia plus nitric acid will make ammonium nitrate. The next gas we'll look at is hydrogen gas, and again it has a number of key physical properties. Like nitrogen, it is a colourless, odourless gas which is insoluble in water. It's also a very light gas, it's less dense than air, it's actually the lightest gas you can pretty much find on Earth. And it's also a neutral substance as well, it's not acidic or alkaline. Now for hydrogen, you have to know a specific preparation, which means making it. You need to know how to make it in a school lab. And the main way we do that in the school lab is by reacting zinc with hydrochloric acid to make a salt plus hydrogen. So when that reaction takes place, hydrogen will start to fizz off the reaction. And we can collect that using a delivery tube, a beehive shelf and an inverted gas jar filled with water in a technique known as downward displacement of water. You need to know a chemical test to prove that you've got hydrogen gas. It should be a test you're quite familiar with. You just bring a lit splint to the gas and you should hear a squeaky pop. There are 3 common uses of hydrogen gas. It can be used to inflate weather balloons, which are very kind of light balloons, flow up into the atmosphere holding meteorological equipment, equipment to measure temperature and pressure, things like that for weather forecasting. It can be used to harden oils, that's how you make margarine. You'll take an oil, you'll add hydrogen to it, and that will make it have a higher melting point, which basically turns it into solid fat, such as margarine. And finally, it can be used as a clean fuel. You can burn it to produce heat, which obviously what a fuel does. The main advantage of hydrogen as a fuel, which I call a clean fuel, is that when it burns, it doesn't actually produce any harmful gases like CO2. And the final section on hydrogen is just the pros and cons of it being used as a clean fuel. The main advantage is it doesn't produce any polluting gases, no carbon dioxide, no other greenhouse gases. The other thing is that it can be made renewably. You can actually make hydrogen by doing a reaction known as the electrolysis of water, and that can be powered by electricity, which in theory you could generate using renewable energy sources like wind power, etc. The main disadvantages of using hydrogen as a fuel are that it's very flammable, which makes it quite dangerous to use. It's quite difficult to store because it's so light, which means the storage is quite expensive. Then finally, even though we can make hydrogen renewably using electricity, at the minute in practice it's not really made renewably. We often make it by a process known as the burning of methane. Methane is a fossil fuel, it's non-renewable, and therefore that's actually a polluting process. The next gas we look at is oxygen gas. Like the other gases, we need to know some physical properties for oxygen. Once more, it is colourless and odourless. It is actually slightly soluble in water, that's how fish are able to get oxygen from the sea that they're swimming in. And they're also a neutral gas because it's not acidic or alkaline. The preparation for oxygen in the school lab is the decomposition of hydrogen peroxide into water and oxygen. Hydrogen peroxide is this chemical H2O2, which will break apart to produce oxygen gas. That doesn't happen very quickly at room temperature, so we need to use a catalyst to speed up the process. The specific catalyst you're meant to know about is manganese 4 oxide. And similarly to the production of hydrogen gas, we would collect that in the lab using downward displacement of water through a delivery tube into a gas jar on top of a beehive shelf. We have a test for oxygen gas, which is where you bring a glowing splint towards the gas, and if it's oxygen, the splint will relight. And we have 2 main uses of oxygen gas. It's used in breathing apparatus, for example for scuba diving or ventilators in hospital, or for welding to melt pieces of metal to each other. Now oxygen is quite a reactive element and will react with lots of different elements. So we look at a kind of sample of 5 different elements that oxygen will react with. We need to know the equations for those reactions and also the observations for those reactions. So these are the 5 reactions. Carbon plus oxygen makes carbon dioxide, sulfur plus oxygen makes sulfur dioxide, magnesium plus oxygen makes magnesium oxide, iron plus oxygen makes iron oxide, and finally copper plus oxygen makes copper oxide. Now, one unusual thing about the oxide you form at the end of this reaction is that oxides can actually be either acidic or basic, in other words alkaline, depending on whether they are metal oxide or non-metal oxide. The general trend we see is that if you've made an oxide that starts with a non-metal, for example carbon dioxide, it will act like an acid. And if you have an oxide that starts with a metal, for example magnesium oxide, it will react like a base. So using that logic, the first 2, carbon dioxide, sulfur dioxide, are acids, and then the final 3, magnesium oxide, iron oxide and copper oxide, are all bases. These are the observations you're meant to know for those reactions. For carbon, the black solid burns with orange sparks to form a colourless gas. For sulphur, the yellow solid melts into a red liquid. It then burns with a blue flame to make a colourless pungent gas. Magnesium burns with a bright white light and forms a white solid at the end. Iron burns with orange sparks to form a black solid. And finally, copper glows red with a blue-green flame and forms a black layer on top of the copper. The final gas in this topic is carbon dioxide gas. First of all, we look at its key physical properties. It is a colourless, odourless gas. It is slightly soluble in water, that's why we basically make fizzy drinks. It's more dense than air, so it sinks in a room, and also it's acidic, as we saw in the last section on oxygen. The way we would prepare it in a school lab is by the reaction of calcium carbonate, otherwise known as marble chips, with hydrochloric acid, and that will make this salt plus water plus carbon dioxide, which can be collected using downward displacement of water using a beehive shelf and a gas jar. The test for carbon dioxide is one you should be familiar with. It involves bubbling the gas through lime water, and if it is carbon dioxide, the lime water should go from colourless to milky. Now in this topic, you also have to know the equation that represents that test using lime water. Lime water is actually a solution of calcium hydroxide. So when that reacts with carbon dioxide, when you bubble it through, it makes calcium carbonate, which is a solid that forms the kind of cloudy precipitate, plus water. Now what you can also find when you're doing that test for carbon dioxide is that after it turns cloudy or milky, if you keep on bubbling carbon dioxide through that solution, it actually goes back to colourless again because a second reaction takes place. Basically, the calcium carbonate you've made in the first step, which is the cloudiness, reacts with water and the extra carbon dioxide you're bubbling through to form something known as calcium hydrogen carbonate, which is a soluble compound, which causes it to turn back to being colourless again. There are two main uses of carbon dioxide. Firstly, as a fire extinguisher, because carbon dioxide is not flammable and can put out flames. And secondly, in fizzy drinks, if you dissolve carbon dioxide into water, it makes the water fizzy. So I've just mentioned that when you dissolve carbon dioxide in water, it makes a fizzy drink. What also takes place is a reaction with water to make the water slightly acidic. So carbon dioxide, when you put it into water, it forms a substance known as carbonic acid, H2CO3, which is basically a very weak form of an acid. That basically means that any fizzy drink, no matter what, is always going to be slightly acidic because of the carbonic acid that's been made from the carbon dioxide.